Hiya, it's Carly from Kit McGrath in Carlisle, and today we're looking at a few different things to do with fractions. So we're looking at simplifying fractions and equivalent fractions. They kind of go hand in hand, and then conversion between improper fractions and mixed number fractions, and going the other way around. Okay, so we've got a few different squares on my board here. We're going to start off with simplifying fractions. And the way that we've got to explain this to children is that we're trying to get to the simplest version of the fraction. So can we divide the top and the bottom by the same number? And that is something that is crucial. It's got to be divisible by the same number. And the other thing that we need to mention is it's not always 2. Children love to half and half and half, and then when they can't divide by 2, they think they're finished. It doesn't always work that way. So we've got to explain to them that it's not just halving, it's dividing by the same number. So obviously my first example is going to be halving because that's the easiest way, but the next one isn't. So what we're looking at is how can I simplify 6 over 10? So what number can I divide the top and the bottom by? Well, they both divide by 2, and this is how I draw it for the children. Divide by 2, divide by 2. To show them they've got to do it to the top and the bottom. So 6 divided by 2 is 3, 10 divided by 2 is 5. Get into the language of saying what the fraction is. So 6/10, 3/5. We read the top before the bottom. That is the simplest version of 6/10. So that's that one finished. 5/15, another one that we can simplify. Children will look at that and say, oh, we can't do it because they don't divide by 2. And we've got to keep reminding them. So we're going to divide this one by 5. So both of these numbers divide by 5. I'm running out of a little bit of space there. Divide by 5. We do the same to the top and the bottom. So 5 divided by 5. Another one where they might get tripped up and say 0. How many 5s are there in 5? The answer is 1. And then 15 divided by 5 is 3. So 5/15 simplifies to 1/3. Okay, or 1 over 3. 1/3, 1 over 3, doesn't matter what language they use. This section here is where I'm going to talk about equivalent fractions. So this is something that they need to understand, especially when we come to adding and subtracting fractions. So fractions can be worth the same as a different fraction. So they're equivalent, they're worth the same amount. A really, really useful toy, if you wanted to buy anything to help teach your children at home, would be one of the fraction boards, which is a kind of a square board, and it will have halves as wooden pieces you can pull out. Then underneath it would have thirds, and it's just really good for practically picking up the blocks and figuring out exactly which ones are the same. You can also get the same thing in circle form shapes. I prefer the straight lines, but the circle form shapes work just as well if your child grasps them better or if they're more affordable for you. So the bottom one down here is just an illustration of some equivalent fractions. I would always start by drawing pies and explaining it that way. So what I would say is, okay, I've split my pie in half. So this section here is a half of my pie. Second time, I have split my pie into quarters. Okay, if I want to colour in still a half of it, I have to colour in 2 of the quarters. So 1/2 is the same as 2 quarters. And then you might say, okay, a half is also the same as 5 out of 10. 50 out of 100. And then you would get them to come up with as many as they can and then say to them, what do they have in common? Well, the thing they have in common is they're all worth a half. But the other thing that they have in common is that the top number is half of the bottom number. And that's how it is worth a half. So that's another nice way of talking about equivalent fractions. A quarter, you could show them that's the same as 2 out of 8 because I multiply it by 2. Multiply by 3 would be 3 out of 12. All of these are ways of talking about equivalent fractions. So those two kind of link quite nicely together. And it's important to do this before you do any other kind of fraction work because every answer in fractions needs to be simplified. So if you can't simplify, you will get the wrong answer, even if you can do all the harder skills. So this one is the one we need to learn first. Now we're going to look at converting between improper and mixed number fractions. First thing is, what are they? Well, a mixed number is exactly what it says in the tin. It is mixed. So it's a mixture of whole numbers and fractions. So this here is a mixed number. Has some whole numbers, some fractions. So it's a mixture. This one here is what we call an improper fraction, because a proper fraction by its term should be less than a whole, less than 1. Okay, improper is where we've got a bigger number on the top than we have on the bottom. What we used to call that in the old days was top heavy, and I still use a bit of that language as long as the children understand what you're talking about. So improper, it's not a proper fraction, or top heavy fraction. So those are our two different types of method of sort of representations, improper fractions or mixed numbers. Generally, when you're doing a maths question, they will expect you to get back to an improper. So you quite often get to an improper fraction and you have to get it back to a mixed number for your answer. Okay? Sometimes you get marks for both, but generally it will specify what it wants. Usually it says, give your answer as a mixed number. Okay, so we'll be expecting to get to this one. But it is useful to know how to go both ways, because you'll need to go from this to an improper to be able to do the calculation, but you'll also need to go from this back to your mixed number to be able to give your answer. So you need to know both ways. So we're going to start off with how to get from a mixed number to an improper fraction. Again, when I first introduced this, I always start with drawing the pictures. So for this one, I've got 3 and 6 out of 7. So what I've got is 4 pies. These ones are 3 full ones, and a full one is still split into 7. I wish I'd picked a nicer number to split. 1, 2, 3, 4, 5, 6, 7. There we go. Not as easy to split into sevenths as it looks, but as long as they look roughly the same. I would say to the children, obviously with fractions they have to be exactly the same, but when we're drawing a sketch to help us do our maths, it doesn't matter if they're not perfect. Okay, so there we go. They're all split into sevenths. And what I would say is, okay, I've got 3 and 6 sevenths. So I've got 3 full ones. So I'll colour all of these in. Colour, 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 colour. And then I've got 6 of these. 1, 2, 3, 4, 5, 6. And then I would say, okay, well, how many is that then? Well, there's 7 pieces here, there's 7 pieces here, there's 7 pieces here, and there's 6 pieces here. If I add them all up, 7, 14, 21, add 6 is 27. Now, once they've got the idea of what we're trying to achieve, we can then explain to them that essentially what we've done there is we've got 3 full pies. So these 3 full pies, which are all worth 7, means that we do 3 times 7, which is 21, add on the top, which is 6, so 21 add 6 is 27 out of 7. Because the bottom of the fraction is always 7, because we've got 27 sevenths. We're always counting how many sevenths we've got. So 27 over 7. Same again here. 4 times 5 to get the full pies is 20. Add on our top, which is 2, so we get 22 out of 5. We've got 22 fifths. Okay, so that's another one. That's how we go from our mixed number into our improper or top-heavy fraction. Now this time we're going to go the other way. So again, we could draw our pies. I don't know why I've decided they're all 7s, but there you go. Now these ones are more difficult to draw. It's more easy to draw them afterwards to check your workings. So if I was to say this, when we're talking about fractions, always try and drop in there that what a fraction is the top number divided by the bottom number. Okay, so we can all do a division. We've practiced that. So what is 15 divided by 7? Well, how many full 7s go into 15? 7, 14, 21. 21's too many. So I can get 14 out of there, which is 2 7s. So I've got 2 full pies made up of 7s, and I've got 1 left over, because 14, 15 is 1 left over. So 2 and 1 7th. So how many times does 7 go into 15? 2 with 1 left over, and the leftover goes over the denominator we've already got. 23 over 4. How many times does 4 go into 23? Okay, so it goes in there 5 full times, remainder 3. And that's how we would do that. And then we could draw our pictures to check it. So say I wanted to draw this one. So I think my answer is 5 and 3 quarters. So colour in the 3 here and count them up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, which is what we had. Okay, so that's just a few sort of brief explanations on how we can do our conversions between these. how we can talk it through and explain it to the children.